Hi, students. Today is Tuesday, November 30th. I'm going to be out for a while, at least until next Tuesday at the soonest. So we're just going to continue our lessons via Screencastify with a sub in the room for the next few days. So today, when you get to class, hopefully you've come in. I want you to get out your algebra book, turn to page 6. Make sure you have something to write with. Make sure you're sitting in your assigned seat. And we're going to be working through our algebra book, and our learning target is going to be talking more about that discrete versus continuous graphs. We kind of touched on it the other day, that word discrete versus continuous graphs. And then we are also going to look at them in tables and equations and stories, and just really be working through what makes that word discrete versus continuous. All right. And so we're going to be focusing on that for the day. Go ahead and pause the video. Make sure that everyone has out their algebra books and that they've turned to page 6, have something to write with, and we'll get started. All right. So here we go. Page 6 right here. It says, please be discrete. Discrete, a solidified understanding task. So we're going to just start with this very first problem right here. We're going to work through it. There might be some new vocab, like the word domain might be a new vocab for you. And so we are going to be really looking at these different story problems and deciding if they are discrete or continuous. And we're really going to highlight some of the domains and ranges of our functions and talk about what those words mean. But before we get started with this, let's go back to what does discrete versus continuous look like? Discrete versus continuous. For those of you that were here or weren't here last week when we talked about it, here's a quick video to refresh your memory. Okay.
Hey math friends, today we're looking at continuous and discrete graphs. A continuous graph, simply put, has no breaks in the graph. So that means that the data in the graph includes everything, everything that you see, everything in between. A discrete graph is the opposite. It has breaks and only includes certain data points. We'll look at a couple examples of these, and then you're going to try some on your own as well. So let's look at each situation here. The first one says the amount of money in your bank account throughout a month. So the first graph here, this would be a continuous graph, and this would be a discrete graph where there's only certain points. So if I'm thinking about the amount of money in your bank account throughout a month, is there constantly money in there, being in there, taken out, put in, or is there only certain points where there's money in there? Well, if I think of a bank account, each and every day and every minute of that day and every second of that day, there's either money in there or being taken out or being added. So this would be the graph for that. It would be continuous. Discrete wouldn't make sense in this situation because at each point in the day, there's either money in there or there's money being taken out or put in. So not discrete for this situation. Next scenario, you are sharing a batch of cookies with friends. Each person receives 2 cookies. So here's a continuous version of this, and here's a discrete version of this. So if each person receives 2 cookies, would it make sense to have a line showing all the data points, or to just have points here for this one? Well, for this one, each person gets 2. So if there's 1 person, they get 2 cookies. If there's 2 people, they get 4. If there's 3 people, there's 6 total. Okay, so those are the total number of cookies. We don't include like 2.5 when we think of people. We don't include other fractions. We don't include decimals when we think of there being a number of people. So this one is going to be discrete. You're only going to have those certain values there. You're not going to have every value in between in the data for that one. So when we look at continuous and discrete graphs, we have to think about the situation, really think about how those variables change throughout. Sometimes it can be kind of tricky, but we need to think realistically about these things.
What? Still searching YouTube for
All
math?
right. So continuous versus discrete. We worked on those back here when we were talking about like the hair on your head grows a half an inch per month. All right. Our hair doesn't just grow every month a half of an inch. It goes from a half an inch straight to an inch, straight to an inch and a half. That would be continuous. Um, and we kind of talked about how these what they could be discrete or continuous and what they would be like versus what we're going to be doing down here. All right, so we're going to start with this first story problem, and we're really going to be thinking about the discrete versus continuous aspect while we make tables, graphs, and equations. Okay, so it says the Library of Congress in Washington, D.C. is considered the largest library in the world. They often receive boxes of books to be added to their collection. Since books can be quite heavy, they aren't shipped in big boxes. On an average, each box contains about 8 books. How many books are received by the library in 6 boxes, 10 boxes, or in boxes? Use a table, a graph, and an equation to model this situation. Part 2, identify the domain of the function, the domain. All right, so I've gone ahead and put it in this right here. Remember, you're just on page 6. You're following along on page 6 in yours, and I am going to be doing it on this Screencastify. All right. So first, we read through it. We do 3 reads. And so now we're going to be going through and we're going to read through it just to understand. So we know we're talking about books. We know we're talking about boxes. And we're talking about how many can be shipped. So let's go through and just underline some important stuff. They often receive boxes of books to be added to their collection. Since books can be heavy, they aren't shipped in big boxes. On average, each contains about 8 books. All right, 8 books per box. 8 books per box. Question is, how many boxes are received by the library in 6 boxes, 10 boxes, or in number of boxes? So what are the 2 things we are comparing? What are our 2 values? We have our x value and we have our y value, or our f of x. And remember, our x value is our independent variable. And this one is our dependent variable. And we're going to be thinking about, does the number of books depend on how many boxes we have? Or does the number of boxes depend on our number of books? And how do we know? And so I think that our independent variable is going to be our boxes. And our dependent is going to be our books, because the number of books we can have depends on how many boxes we have. So our independent is our boxes, our dependent is our books. And they gave us some information. Each box contains 8. So one box has 8 books. 2 boxes would have 16. 3 is going to have 8, 16, 24. All right, and we're going to continue our table. So it says use a table, graph, and equation to model this situation. I'm going to stop really fast. Is this going to be a curved graph or a straight graph? Is this going to be linear or geometric? And how do you know? Okay. If you said linear and a straight graph, you are correct. This is going to be adding 8. It is a plus 8 for every box. It's a plus 8. It says it's changing 8 books per box. It's changing 8 per box. It's plus 8. So this is going to be a linear equation. All right, I'm going to go ahead and I'm going to add to this. I'm just going to keep going. Pause actually and do it, and you can catch up. All right, so I have 1 is 8, 2 is 16, 3 is 24, and so on. I just kept changing it by 8. We've made our table. The next thing we need to do is we need to make a graph and an equation. So let's go down. Let's talk about our graph. I've just drawn it on here. The y that points to the sky, this is going to be our dependent variable, our number of books. So let's make sure that we write our title and our label. So this is going to be our books. This one down here, our independent variable is going to be our boxes. Okay. And then we have all positive values here. We already know it's going to be a linear equation because it is changing with addition. And so let's kind of talk about a scale. A scale. If I want to get up to at least 6 on my boxes, I can go 1, 2, 3, 4, 5, 6. Maybe I'm going to skip one. 1, skip 1, 2. And then remember, this right here is our 0. This has to be our origin, our 0 right here at the thing. And then I'm going to go 1, skip 1, 2. Our scale has to be consistent. 3, 4, 5. And you're doing this in your book. You're following along on page 6 and 6. Now let's look at our dependent variables. And we have to go from 8 to 48. Well, 0 boxes is going to give us 0 books. So maybe I'm going to go by 4s. Let's try 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44. 4s is pretty stinking close. Let's go by 4s. Okay, I'm going to pause it and write them down. You go ahead and go by 4s also. All right, so started with 0. I decided to go by 4s all the way up. You might go by something else, okay? Now, I know that if I had 0 books or 0 boxes, I could ship 0 books. So there's our y-intercept or our initial value. We can call this the y-intercept. Sometimes we call it the initial value. Sometimes we call it the 0 term. All of those will work when we have this 0 right here. So the 0, 0 is going to be our starting. It's going to be where it crosses this y that points to the sky. All right, and we're just going to go ahead and we're going to graph this. 0, 0 is going to be right here. Oops, let me go grab a drawing tool. Okay, that's going to be our first one right here. Then we're going to have 1 and 8. 2 and 16, 3 and 0, 8, 16, 24. Sorry about that. Lost my train of thought for a second. 32, 40, and 48. All right. So we have our table and we have our graph. Now let's talk about this. Should I connect this or should I not? Can I ship a partial book or can I ship a partial box? The answer is no. I can't ship a partial 3/4 of a box, who has just a few sides and missing a side. No one wants a partial of a book. So we're going to have these gaps in between. We are not going to connect this. This is going to be discrete graph. It's going to be a discrete graph, which means that it's not going to connect, or the lines or the points. Okay, we're not going to connect the dots or the points. Okay, because I can't have a partial. Let's go ahead and let's make our equation really quick. Our f of x is equal to, remember our linear equation, it's going to be its rate of change, which is 8 per x, and it's going to be its 0 term plus 0, or you could just say that your f of x, see, man, I'm struggling here today, is equal to my 8 per x, 8 per box, okay? Let's go back up and see if we answered this question. It says use a table, a graph, and equation to model the situation. Identify the domain. The domain is the x values. So if you think about a whole nother vocab word, we've called it independent and dependent. We've called them x's and y's. Now we're going to have the domain. The domain is the x values. And so the domain is going to be all whole numbers, right? Whole boxes. We're going to learn how to write this mathematically. So, oops, darn it. Let me undo that. All right, so for now, we're just going to identify the domain. The domain is your x values. And we're going to identify them as our positive whole numbers. So when I get back, we are going to learn how to write this mathematically. But right now, we just want to say that they are domain is positive. There are no negatives. You can have negative boxes. And they're whole numbers. They're whole increments. So it's going to be positive whole numbers. And our domain is our x values. Okay? So right here is your new vocab word. And we are going to identify them, our domains, just as positive, negative, real numbers, rational numbers, whole numbers. How are we going to identify them? Okay. All right, let's go ahead and go down to the bottom of page 6 here. It says many of the books of the Library of Congress are electronic. If about 13 ebooks can be downloaded on a computer each hour, how many ebooks can be added at the library in 3 hours, 5 hours, in hours, assuming that the computer memory is not limited? Use a table, graph, and equation to model the situation and identify the domain. All right, that's what we're going to be doing next. All right, so we're doing our 3 reads here. The first one we just read through, it's still talking about books, but this time it's talking about ebooks. And about 13 ebooks can be downloaded on computer each hour. So we have our 2 variables here. Our 2 variables are ebooks and hours. All right, so we have to ask ourselves, which one of these is our independent variable? Which one is our dependent variable? Remember, independent is our x variable, our dependent is our y. So we're going to ask ourselves, does the number of books depend on how long they download, or does how long the time change by how many books that we have? And that one's pretty obvious. Obviously, the hours, time doesn't stop just because the download stops. So the hours is independent, and the amount of downloads is the dependent. How much can download depends on how many hours, okay? And so we're going to say if 0 hours, we're going to get obviously 0 downloads. At 1 hour, it's going to be 13 ebooks. It's changing. 2 hours, 26. 3 hours, 13, 26, what, 39, is that right? 4 is going to be 49, 50, 52. And remember, if I'm writing it, you're writing it. 65, that's probably good. Okay, so our independent is our hours, is our x. Our dependent is our y. And we have it going on here. So it says, how many ebooks can be added to the library in 3 hours? Well, 39. 5 hours, 65. And so on. Use a table, graph, and equation to model this situation. So we have our table. Our graph, remember our y value is our downloads. Our x value is our hours, time. And we're going to decide on our scale. Well, our scale probably should be, I'm just going to go ahead and pause it and write it down. You figure out your own scale, I'll figure out mine, and we'll re-meet up here in a second. All right, so I decided to go by skip 1, 1, skip 1, 2, all the way to 5, and I decided to go by tens on my y. Okay, yours might look different as long as you are consistent. If you decide to go by tens, you go by tens the whole way. If you decide to skip 1, 1, skip 1, 2, you do that the whole way as long as you're consistent. So I'm going to go ahead and say 0, 0. I'm going to be at the origin. If I do 0 minutes of downloads, I have 0. 1 is going to be 13, which is about right here. 2 is going to be 26. 3 is going to be 39. 4 is going to be 52. And 5 is going to be 65. So now the question becomes, can I have a partial of an hour? Do I have 0.6 hours, 2.3 hours, 3.7 hours? The answer is yes. Time is continuous. But can I have a partial of a download? Can I download a partial of a book? And the answer is also yes. So since I can have a partial of an hour and a partial of a book, this is a continuous graph. I'm going to connect, continuous connect. I'm going to connect it. And it's going to be linear. It is 1 for every 13. So it is a linear graph that is continuous. It is connected. This is a continuous linear graph. Okay? And since it's continuous, we also know that f of x is going to equal to, it's changing 13 per x, and started with 0. 0 time passed, I had 0 books, or I could say my f of x is equal to 13 per x. Now notice, from my story, I can tell it's continuous, and from my graph, I can tell it's continuous, but from my table and from my equation, I cannot tell. I don't know the story behind it. I cannot tell if it's continuous. Okay? Finally, it says identify the domain of this function, the domain. Well, the domain, remember, is another name for our x values. And in this case, it is all positive. And what do we call numbers that include all of their numbers? 0, 1, 2, and all the numbers in between. Let's go and let's look. What are positive? Let's do classification of numbers. Let's just look and see what we find out. What are the 4 types of classifications of numbers? So natural numbers are positive integers that don't include 0. Whole numbers include 0. Why is this not? Rational, irrational. Let's look again. Let's see if we can find the chart. All right, here's a good one right here. Okay, well, maybe. Here we go. All right, so natural numbers are like counting numbers, 1, 2, 3, 4. Whole numbers would be including 0, 1, 2, 3, 4, which is why up here we called them whole numbers because it included 0, but they were our counting numbers that included 0. So here we don't want all integers because we don't want negative numbers. We want rational numbers. These are all numbers that can be expressed as the division of an integer, fractions or decimals. So we want rational numbers. All right, we want all the numbers. We want the ones that are fractions and decimals and ratios. We want all the numbers in between. So we're going to call this x values all positive rational numbers. And that's going to identify our domain. Our x values are going to be all positive because we can't have negative time or negative, but we want the rational numbers, which includes the fractions and the decimals and all of that. And that's going to include all of these numbers plus everything in between. Okay? So your job is we're going to go ahead and you're going to be working through number 3, number 4, number 5, 6. Let's see. Well, let's just go through as many of them as you can. All right. I want you to decide how much time there is. I want you to go through as many of them as you can. And then we are going to talk about them tomorrow. So we did all of page 6, page 7, page 8, page 9, and page 10. Okay, so you're going to be going through page 10, work with a partner, see if you can figure out what it is. If you get stuck, Google an answer. Google what is the domain? I forgot. What does it mean? You should be able to figure out if they're geometric or if they are linear. You should be able to figure out if they're discrete or continuous. You should be able to make tables, graphs, and equations. But work together, and I'll have an answer key tomorrow to go over these. Okay, so your job is to finish pages 6 through 10. Have it ready at the beginning of class tomorrow.